So thanks to John and Jerry and Richard for inviting me. It's quite a pleasure to be back under the tent. I'm a relative newcomer here. I started in 2006 with a famous CMIP-5 experimental design, where we came up with a carbon cycle diagnostic experiment, and Naki said, hey, we've done runs since Ezra's, let's do some new scenarios. And then at an energy modeling forum meeting, which I will also add is a nice complement to the Aspen Institute, I was giving a summary of the carbon cycle experimental design and said that there's going to be this land use planning meeting because we need to get things consistent, when there was no land use planning meeting. But that started it. You know, so sometimes if you just stick your foot in the mouth, things can happen. So I wanted to sort of give you guys a sense, to follow the directions here and give you a sense of how my path has evolved. I was called a gypsy modeler back in my postdoc days because I traveled back and forth between the University of Montana, where I worked on Biome BGC, and Corvallis, Oregon, working for Ron Nielsen and his group, trying to develop a model that was a hybrid between biogeography, cohort stand dynamics, and biogeochemistry. And that model still works, and they use it, but it's mostly for the Forest Service and national assessments. So I've actually wandered quite a bit in my life. But in the beginning, when I started my ecological tour de force, if you will, back in the 80s, there were two kinds of ecologists. So I'm an ecologist by training. There were the armchair ecologists who sat back in their comfortable sofas and developed these equations that described how the world works. You can think of the logistic equation, you can think of Lorenz, you can think of chaos theory, foraging theory, all kinds of things. And then there were frog squeezers. Frog squeezers were the ones that were out in the field taking the observations, the measurements, very descriptive, sometimes experimental, really trying to understand the meter squared that they lived in. And I kind of like the idea of both. You know, I always needed to be outside. I still do. And the idea of modeling, when I took population dynamics as an undergrad, was the first time it really made me think about how a system works. I was raised to be a concert pianist. So for me, the math part was pretty easy. And all I had to do was memorize patterns and play. I was a soloist. So, you know, it was what I was supposed to do. But modeling made me think about how a system really works. And then, of course, having to be outside ruined it for me for music. Because it was really hard to cart, you know, an upright grand or a viola, because I was in chamber orchestra. The viola wasn't so hard, but it was hard to get cellos and bass and stuff like that around. So that was kind of what motivated me to get started. I've never really had a particular focus other than understanding how change or disturbance impacts different kinds of systems, primarily land systems. So just to give you a little history, starting from the 80s, most of you might be a little surprised that I started with birds. I was really interested in bird ecology and bird evolutionary history. I worked at the Mountain Research Station. I lived up there for 3 years, sometimes in a tent, sometimes in a 10 by 12 cabin, splitting my own wood, hauling my own water, where I ran a bird nesting phenology for 3 years in the very early days of LTER. It was heaven, you know. I was living in a cabin, I was doing field work, I was understanding how a system worked, and I got to contribute to grass harvests and small mammal harvests and things of that nature. It was really great. For my master's work, I took it a little bit further, and I wanted to work on a model that helped us understand how the consequences of agricultural productivity in Idaho near the Snake River might be impacting the foraging success of raptors. And I was working with the model that Jim Gesseman and others developed for the Snake River bird of prey area. So I raised kestrels, and I got to play with, you know, eagles that were being rehabbed and other things up at the McDonald Raptor Research Center, and doing an experiment on limited food supply and seeing how the birds responded. Brought the birds back to Colorado State and analyzed them for body fat and bill depth and things of that nature to see what the metabolic consequences of limited food might be for those birds. And then I worked briefly for the Forest Service and the Division of Wildlife, looking at how white-fronted geese habitat was being used as they moved from Alaska down to Sacramento Valley, which is where they staged going on and spent the winter. And they staged in Northern California, and then they spent most of their winter in Sacramento Valley, you know, foraging on grain harvest and set-aside programs, which goes with the agricultural community because that community sets aside 10 to 20% of their lands for the geese. And this is just what happens when you have a power lifter letting a goose go, the poor thing, after we had put a telemetry device on it. And then I really wanted to pull this field experience together with modeling. So what really inspired me to get going in this was Steve Archer, a rabid field ecologist at South Texas at the time, and Dave Schimmel and Bill Parton working on the Century model. So I was able to pull together, this is where this interaction between what's going on in the field and how a model represents what's going on in the field really needs to be kind of dovetailed together. So I worked with the Century crowd and developed a parameter set looking at the nitrogen cycle, looking at the consequences of grazing and fire suppression on the South Texas savanna. That had evolved from a very simple system, grasses as tall as a horse's chest, to a very diverse thorn scrub woodland. So what's better, the higher biodiversity or a simple grass system? It's hard to say, but this is what it is now, and this is where it will stay. So I worked on the nitrogen cycle, I worked with the Century crowd, and it turns out that the parameter set that I developed, I found out from Dennis Ojima just a few years ago, for the South Texas site is the default parameter set for the savanna model. So it's actually robust for their default parameter set for the savanna model globally. Fast forward then, after my postdoc with Steve Running, and I mentioned a little bit of the work I did with Biome BGC, I was sitting at the Wash Basin, University of Montana on a Saturday. There was an ad for a science officer to work for GAME, working for the International Geosphere Biosphere Program, and I thought, oh, that sounds like fun. I bet I'd learn a lot if I went and did something like that, but who am I? I went and applied and they hired me. So I worked for the GAME project under Barry and Moore and Will Steffen and others for 5 years. I helped get the Carbon Project started, wrote the science plan for that with Will, Mike Raupak, Barry and Moore and others. And we launched that Carbon Project, in light of the Earth System Science Partnership, the ESSP, at the Amsterdam meeting in 2001. And I'll talk a little bit more about some things that are more relevant to this meeting as a result of those interactions with GAME, and that was how do we think about bringing the carbon cycle and biogeochemistry into the climate system. But anyway, more about me. Took a hiatus. I promise this will end really quick. Took a short hiatus, did 2 years looking at the consequences of catastrophic fire on the east side of the Cascades in Oregon, where I worked with Bev Law, and we set up a bunch of plots, hectare-sized plots, looking at standing dead soils, vegetation recovery, all kinds of things, in the Irely fire just north of Sisters. We were very, very lucky in that we got in just a couple of months after the fire and were able to follow the trajectory of change for several years. After that, I got a call from my old friend Dave Schimmel, who said, IGBP is talking about moving the GAME office, which was closing down, to NCAR. Would you consider coming back to the international community? And I thought, wow, that'd be really fun. I'd love to be back in Boulder. And although I love being paid to do field work and modeling in the wintertime, this was something that I developed a taste for when I was in New Hampshire. So I came back to manage the Ames project, which is where I met many of the folks here in this room. And I'll talk a little bit more about what we did there. But essentially what we were looking at is how do we think about coupled human and natural systems? How do we think about talking to the communities that need to make this happen so we understand a coupled Earth system in a much better perspective? And then after 5 years of that, I started thinking, I really want to think about how I can understand more national interests, because I was working very much at the international scale, and I really didn't know what was happening in my own country. So for about 5 years now, I've been with the Pacific Northwest National Lab, working on a regional climate, energy, land, and water system that I'll talk very briefly about. Jay will talk a little bit about it, and Richard will talk a little bit about it as well. But the overarching theme is how do systems respond to change? Whether it's human caused, whether it's natural caused, it's always both. There's always two sides to that coin. There's always multiple interacting factors that lead to either incremental change that we've talked about a lot today or very sudden change. So we don't always know what those drivers are, but that's what's driven me. I like to think about the evolution of the carbon cycle. A lot of people have talked today about the history of their science, and I think in more general terms, even in Earth system science, in the 50s, we started with a very descriptive perspective, and we're evolving into a much more predictive capability. When I think of descriptive, I think in terms of the carbon cycle for the very famous Keeling observations on CO2 flask observations in Mauna Loa. We started understanding what the carbon cycle was doing from a global perspective. Then came the evolution of new technologies and new ways of thinking about budgets and fluxes, whether it's eddy covariance, Argo floats, or other kinds of observations that we're taking to understand the carbon cycle from a much more integrative perspective. And then in the 2000s and beyond, and I'll talk a little bit more about the beyond towards the end of my talk, we're starting to think more about what are the processes that drive the carbon cycle and changes. How do human systems actually interact with that system? And this was shown earlier this morning. I'm going to start here with the carbon cycle, where we were trying to think about how does the carbon cycle interact with the climate system. And I think, I forget who it was this morning that talked about, making, I think it was Jeff, taking, huge leaps of faith, right? Well, Inez, I think it was Jeff that said no. It all started back in the late 90s when Inez Fung was down at a WCRP meeting, I think it was in Hobart, and she proposed this idea, what if we bring the carbon cycle into the climate models? And it could be a catastrophic failure because, the models were so susceptible to chaos, and it just, they didn't know if it would be stable. So I just kind of took this as a starting point. It's an IGBP newsletter, and she says, glimpses of realism should be hoped for, but their absence should not be cause for despair. We've learned a lot from our model intercomparison activities. So we called it the flying leap at the beginning because we might end up straight on our nose. Okay, I'm going to run through this. We all know about Friedlingstein's paper and AR4, then the CMIP5 experimental design, and then some of the results from AR5. Currently, what's going on now, we have some OBS for MIPS and NASA DOE activity trying to think about how do our observations, satellite observations, fit in with model comparisons. Jay's I'm going to talk a little bit. We have a global integrated Earth system modeling capability that we're developing between the integrated assessment model GCAM and the CESM model. And this is what I've been working on the last 5 years, is how do we think about regional integrated assessment, in other words, energy technologies, land use, regional Earth system, and sectoral models, for instance, with regards to energy systems. The one point I really want to make at this talk here is that it's not all about a 10-kilometer grid scale, because what's going on at 100 meters, 10 kilometers, or 50 kilometers isn't necessarily reflected in the human scales of operation. When you think about the energy system, the US is divided up into these regions here. This is the western region, of which the Northwest Pacific Power Pool is a subregion. And then I just gave a talk a couple of weeks ago to the Puget Sound Regional Council, which is the consortia of 4 counties on the west side of the Cascades and near Seattle. And this is their region of interest. This is where people say that I want information in my own backyard, but if you don't have an understanding about how energy systems are interacting at these larger scales, you're going to miss a big boat here. Okay? So these are the scales that the energy system and the grid operate at, but our modeling system takes these scales and maps them more conveniently to the state level, which is okay. You can think that this is the Northwest Power Pool, and then this is the modeled Northwest Power Pool that GCAM is working on for downscaling. And these are the downscaled power plant locations that we're actually incorporating into our energy sectoral model. This is a result from whether or not you have carbon sequestration. Big point here is if you have no CCS, energy prices go down because carbon prices go up, energy demand goes down. And a big difference in whether oil or gas. We also have an operational hydrology model that looks at, again, these are the scales of operation for the hydrologic regions. These are the operational systems that we actually include in our model. We don't include individual operations, but we have a generalized system of operations. It's a start. These are some results for the Pacific Northwest that, believe me, coincide very nicely with these observations, from 1948 to 2008 for the Pacific Northwest. and some of Phil Mote's work on looking at projected summer flows into the 2040s and comparing them. So we're seeing rain on snow, warmer summers, higher demand for agriculture, higher ET, longer growing season, all kinds of things interacting to change the hydrologic cycle in what is thought to be a very rich area. Sea level rise issues with regards to Puget Sound. One overlying thing that's not considered in a lot of these systems is what's happening with the politics. The Columbia River Treaty is currently under negotiation. We don't know what Canada's going to do. It's a big deal. So we have these sort of really nice modeling results, but I had to give a plug. We've seen a little bit of this before. We've got some new stuff coming out from a project I managed under AIMS called I Hope, the Integrated History and Future of People on Earth, that have looked at how the Maya civilization was influenced by the environment, but it was really how the Maya elite redirected all their resources into developing more infrastructure to capture water that wasn't there. They died out, but the Maya people survived. Michelle Hegman has a really nice treatise for the US Southwest that looks at the drought at that time and 3 different modes of operation of how humans responded to that drought. They either migrated, they were cannibalized, that was the Anasazi were cannibalized. The Hohokam did exactly what the Maya did. All of their resources went into infrastructure. There's more details on that. So my summary, Summary, there's all kinds of scales. We've been talking about scale all day, and I've been just sort of sitting there thinking, this is really interesting because this is some of the challenges that we've had to meet with this regional framework is actually thinking about how do we think about energy scales at these level, hydrologic scales, grid scales that are changing all of the time, interfaced with scales that are happening on the political scene. It's not easy. But we have, without this sort of interoperability of the models that we've developed, we wouldn't be able to think about these things. And Richard will talk a little bit on Wednesday about how this helps our uncertainty analyses. From the climate assessment work that I was able to contribute to, every region will have its own unique characteristic suite of challenges. For the Pacific Northwest, sea level rise and subsidence. This is an image from a flood that happened in 2009 in Seattle. Now, this is also a function of land use change over the last 100 years. Because this area is no longer forested, it's been converted to agriculture. So the land is more vulnerable to extreme winter storms. Bottom line, there's no silver bullets. There's no easy solutions. Informed decisions is what we need. We need to let the public and the policymakers understand that there's not one answer to our problems, but we have to be able to provide this information in a very concerted and reasonable way so they understand the consequences of their decisions. And impediments, we've all heard this before, there's stovepiping and funding agencies, and what we've talked a lot about today is the communication, terminology, and education to move on. And I think, yeah, so I just wanted to say thank you. And thank you too, especially to people that have known me struggle over the last 10 years with actually walking. This is a picture I took a few years ago on my very first hike up to Buckskin Pass from Maroon Bells. So my feet are fine. Thanks, everyone. Let's close in.
Kathy, Jay, why don't you come up and get queued up? While Jay's queuing up, there's a quick question.
Q&A.
Oh, he's...
No, just queuing.
Anybody, any whirlwind tour?
You made a statement there, communication, education in its infancy. I wonder if you could just say a few more words about that.
I think that we've tried to start, the work that people like Susan Hassel and others do. I think that Climate Central is also trying to help with that process. But I think more importantly, we really need to have a venue to educate my mother. I mean, there are a lot of smart people out there that aren't educated. And they really just want to understand this thing from a perspective that's not so ground in the details. And I think that's what's really important. And it starts at a young age. I also really believe in 0 to K, K to 12, and then the undergraduate level. I mean, people, if you just have an understanding, if you can just be educated,